When you first start learning machine learning, what do you focus on? Probably models, right? You dive deep into accuracy, algorithms, and different architectures, but let me tell you, in the real world, machine learning is so much more than just the model. A model is only one small piece of a huge, complex system. Think about it. A real-world machine learning system has to handle everything: data collection, building data pipelines, feature engineering, managing the infrastructure, deploying the model, constantly monitoring its performance, and pushing updates. You could build the most accurate model in the world, but it could still completely fail once it's live. Why does this happen? Because models don't fail with a big, loud crash. They fail silently. The data you trained it on starts to drift. The way users behave changes over time. Your company's business needs evolve. If your system isn't built to detect these silent shifts, your model's performance will slowly degrade, and you might not even notice until it's too late. This is a key difference between machine learning systems and traditional software. In a normal app, the logic is mostly fixed. You write the rules, and it follows them. But with machine learning, the system's behavior is driven by data, and data is never, ever stable. It's constantly changing. This is why a machine learning system is never really finished. It's a continuous, iterative process. You start with a goal. You collect data. You train a model. You deploy it. And then this is the crucial part: you monitor how it behaves in the real world. You learn from its mistakes and its successes. And then you start the whole loop all over again. This loop isn't just a nice-to-have feature, it is the system. Another big misconception is that you should use machine learning for everything. That's just not true. Honestly, if a simple rule-based solution gets the job done, it's almost always the better choice. It's easier to build, easier to understand, and easier to maintain. Machine learning really only makes sense when the patterns you're looking for are too complex to be hand-coded as rules. When you have a massive amount of data and when the predictions your model makes will create real tangible value. At its heart, machine learning is about one thing: prediction. It's not about reasoning or deep understanding. If you can't frame your problem as a prediction task like predict which customers will churn or predict the price of this house, then machine learning is probably the wrong tool for the job. Finally, when you're building a real-world machine learning system, you have to think way beyond just accuracy. Is your system reliable? Can it scale up as your user base grows? Is it maintainable? Or will it become a nightmare for the next engineer who works on it? Is it adaptable to change? A system can have 99% accuracy and still be a total failure if it's not reliable or scalable. This is why production-level machine learning is less about finding some clever new algorithm and more about solid engineering. It's about designing robust systems that can not only perform well, but also survive and adapt in our constantly changing world. Thanks so much for watching. If you found this helpful, hit that like button and subscribe for more insights into the world of machine learning. See you in the next one.